Yeah, actually, I meant to say this before we finished, but we kind of ran out of time. Is that there's some more. These are some other examples that I did with that terrain loop on my daily sketches. So one of these, this is a similar example, but adding rotation to the forms. So kind of they like have these different angles, and they're kind of like pointier in a way, and also a slightly more difficult one to pull off. It just takes some math, but actually quantizing the height so that the cubes all sit exactly on top in these layers. So a couple other kind of ideas of where you can take this look. So the next example we're going to look at is, let's see, we can look at these examples, this kind of rising like bubbles that loop. And I was actually inspired by Dave Beesbaum's. If you don't know Dave White's work, he makes these amazing looping animations. And so this one was a really simple kind of rotating cube, but I really liked these like spheres that had this gradient shading on them, and how they would kind of like bubble and then shrink. And this one, this is a loop, so so I was like, oh, how do I make that? And so that was what inspired kind of this next few that we're going to look at, these next couple. So and definitely this one, you can see, I'm directly kind of like referencing that look. So let's go ahead. I'm going to start with a new TouchDesigner. And everyone can hear me, correct? I didn't see any comments, but I just want to make sure that I'm okay. Great. So let's go ahead and start from scratch this time. And in this case, I want that same kind of like loop, that timeline loop to start. So I'm going to create timeline, and just good practice to do it. And add a math, divide the channels again, so that I have my kind of like ramp counting up, and I'll create a null and call this ramp for future reference. One thing in this case, when I was kind of approaching the problem, I'm thinking, okay, there's all of these different instances. They're all kind of like in the same position, but moving upwards. So what I want to do is first generate a bunch of varied loops. They're not all growing and shrinking or moving at the same time. So I'm going to use noise for this. This is going to be my kind of like displacement in terms of the y-axis, and also I'm going to use it to drive the scale so that they get larger and smaller. And one other thing that I'm going to want is a little bit of control over how many objects I draw. And so I'm going to start by kind of creating a constant right off the bat. Call this PARS, pairs. And in this case, I can just call this samples, because we're going to be working with chops in this example, which are still super useful for working on instancing networks. And the number of samples, I'm going to start with 250, but we can certainly scale that up or down. And because we're going to be referencing this value, that'll make our network especially flexible. So I've got my noise. I actually want this to be random, so that everything is just a random value between, technically I want it to be between 0 and 1. So I'm going to change my amplitude to 0.5 and the offset to 0.5, so that it's all offset from the middle, and our values range from roughly 0 to 1. And I also, right now, if I middle mouse over this, we have 600 samples. That's what the 600i is telling me, which is not the same. So I'm going to go to the channel on my noise, and again, this is in seconds, 10 seconds. This is the unit. So let's change this to samples, and I'll open the parameter, the viewer here, the chop viewer, drag my samples over to the end, and for a while, this was like something I had to wrap my head around. Is technically I have 251 samples here, so it's going from 0 to 250. But because it's 0 indexed, we actually need to subtract 1 from the end. Otherwise, so I'm just going to type -1. Otherwise, we don't actually have 250 samples. So this is something that can, cause a little bit of some issues if you're not paying attention to it. So, this one's going to be 0 to 249, and that's going to give us our correct number of samples. So, so this channel right here, we're going to basically, we want this to, each one of these points as our frame increases to move up and then loop from 1 to 0 and then back again. We basically want to create a bunch of mini ramps, like a bunch of ramps, 1 per sample, that are offset based on this noise. So to do that, I can select this ramp, and I made this math chop, actually without talking, but I made this math chop, and I'll plug this in, and it's kind of doing some crazy stuff right now, and I'll go ahead and combine the chops and add them, and you'll see that it's still, still not doing what we want. So this has to do with the alignment, and I could, extend to min-max, or stretch to min-max, for instance, but this starts to cause, I find I sort of prefer to leave this as automatic. And why this is happening is because this frame coming in, this select, is a time slice. So we're actually starting and ending at the current frame. And that's why, if you look at the bottom, we have this timeline for our chops. But we want this to start at 0 and end at 0 so that it's not moving around, and that will actually prevent any of this from happening kind of in the future. So this is just a clean way to do this. So I'm going to add a trim before the ramp and choose absolute. So what this is doing is it's just like repositioning our sample, which is moving through the timeline to 0, 0, and it's just staying at that position, the start and the end. And you'll notice how when this is aligning automatically, we're not getting any weirdness here. So that we're going to do that, and that means that any future times that we use this value, we don't get anything funny happening. Okay, so yeah, beyond that, right now we have our values increasing, but we want them to loop between 0 and 1, so that when they go past 1, they come back to the bottom. And so a really useful way of doing this is the limit chop, because we have a loop option, and we can choose the minimum to be 0. So now if you watch each value, when it gets to the top, it pops down to the bottom, and it's linked to our timeline. So we have a whole set of offsets, like a bunch of different ramps that can be used to drive different behavior. So the next step, now that we've got our data here, is let's actually kind of set up what we want to draw. So in this case, I want, they could be spheres or circles, and this would depend on kind of what you want to do with it. I'm going to start with a circle, because this example, we're just looking directly at it. But if you want to move the camera around at all, you can also use a sphere for this. And I'll choose a small radius of like 0.1. Maybe we'll make it even smaller. I'll see. And I'll plug this into a geo comp. So I'm basically going to build a render network again, add a camera, a render, and I'll set this to 1080. 1080 again. And just so that we can follow along on the right panel, I'll split the panes, set this one to a top viewer, just get this so that it's hopefully easy to follow what the output is. And then turn off backdrop tops. Okay, so that hopefully will be, we can always see what's happening over here. And I'll also grab a constant material and drop that on, just so that we have, we can see it. And kind of like lastly, what else do we need? I think that's good. Oh, might add, we'll do that later. Sorry. Cool. So the next thing we can do, I know that I want to use this for my scale. So I'll set that up. We won't actually see anything quite yet because it's all in the same position. But let's go ahead and use this for our scale. So I'm going to use a lookup chop. So essentially, this is like the same as our lookup tops that we were using. It takes values from the index range, in this case 0 to 1, and it will kind of look up the value along the timeline of whatever pattern I add to the second input, the lookup table. So in this case, I kind of want the circles to like grow and then halfway through the process be at full or maximum size and then shrink as they get to the end of this ramp. And so what I'll do is for this, I can just create a pattern chop. It doesn't matter how long this is because it's going to be the length of our, this lookup, the index that's coming in. So, so this can be any length. I'll use a cosine, and then right now it's kind of reversed. So instead of going from 1 to -1 to 1, I want to change this from range to 1, and then the to range to -1. So we're now going 0, 1, 0. I chose a cosine just because I want to kind of get this ease in and ease out. And that's just one way to do that. So we'll plug this into the lookup table, and now you can kind of even see that the motion has changed a little bit in the values. I'll call this, I'm actually going to go to the channel for pattern and call this scale, just give it a name so that now we've got something we can use for our instances. I'll create a null, give this a name, instances. And for my geo, I can just start by turning instancing on, dragging my instances to the default instance operator, and for scale, we just want scale for everything. Oh, what did I do? Pasted something, sorry. X, Y, Z. Okay, great. So again, nothing's happening here. There are, 250 circles getting smaller on top of themselves. But we want to now position them in space so that they're, we can actually differentiate them. So what I'm going to do is use more noise for this. So in this case, I can copy my existing noise just because we've already gone through the process of setting up the length. And I still want this to be random. Under the channel tab, let's use this to generate X, Y, and Z positions. So I'll type T, and then I like to do this as a shortcut. Use the left bracket, X, Y, Z, right bracket, which generates TX, TY, and TZ. It's a type of pattern matching, which you can read more of. There's some different pages on the derivatives kind of documentation about that. You can also just type TX, TY, TZ separately, but this is just a shortcut. And so this is going to be our kind of position data to position them. Now, one thing that we'll actually notice, I can leave it here if you want, but if we'll need to change the seed in a moment because otherwise it'll be lined up with our scale as well. So I'll actually go ahead and do that. So this gives us another set of random values. And for now, let's just create a null, and I'll call this position, and then a merge. I still am in the habit of merging all of my instance data together. You don't technically need to do that. You can drag your own operators on here for the different translate or rotate. I just am still very much old school in that sense. But yeah, now that we've added X, Y, and Z, we can type in TX, TY, TZ, and we can see, okay, great, we've got ourselves circles in different locations, and they're getting smaller and larger and smaller. So one thing I want to do is, instead of going from 0 to 1, let's actually center this at 0. and add a little bit more of an offset, an amplitude. So I'll drag that up a little bit. So now they're dispersed a little bit more throughout the scene. Another thing that I want is, I'm happy with where the TX and the the TX and the TZ are positioned, but I do want the Y, which is this vertical axis, to be moving with my this kind of like looping ramp data. So what I'm going to do is I can just select that if I'd like with a this is just a cleaner way. I like the select way of doing this. And I also want to split off the Y channel. That's what I'm going to add to this. So I'll use another select, use the drop down to grab TY. And then because I don't want TY over here, I will add another select in this, so right clicking. And this will only be TX and TZ. So now you can see that we don't have that vertical axis anymore. And then for these, basically I just need to add them together. And because this loop lines up with my scale being at 0, we're not going to see any weird discontinuities with it jumping, through the, like, just blipping out of existence. So, okay, so I've combined these, not yet. I need to choose combine chops and add them. And now you can see that all of that data is just kind of moving upwards. And I'm going to go ahead and, I can merge it back here. I could merge it up top. It doesn't matter. Okay, cool. So that's, we've already got a lot of our motion defined. We might want to tweak it a little bit. For instance, like this, the Y values, we might want to move it down a little bit so it's in camera. You could also just move the camera. There's always 2 ways or more to do everything. So I'll create a math after this, and in the mult add, I can just subtract some so that it's more centered. It's also, I might want it to move faster. There's different ways to do this, but we can always change the timeline. So for now, let's maybe set this to 400, get it moving a little bit quicker. But yeah, so there's our circles. The next step is, if we remember the example that I was originally inspired by, we have this kind of like gradient on each circle. And, there are different approaches to this, but the method I found was first to create our ramp of color options. So I'm going to just choose, create a quick ramp here. Colors that we will apply to our circles. Can really be whatever you want. It is good for this to loop on either side though, so I'll take off that last stop. That way we always have a continuous ramp. And then also, I'm going to make this a vertical ramp because I want the patterns to be vertical. I'll make a null just in case I want to swap out, a different ramp later. It's always good to just use nulls at the end of chains. And then my constant, I'm going to drag null 2 onto the color map. And okay, so we're getting closer. Now each one of them is the whole spectrum of this ramp, but we really want each one to be a different, smaller portion of it. So the first step can be accomplished using a texture stop right after the circle. And this lets us, one, choose how our texture is being mapped to the geometry, but also the scale. And in this case, I'm going to drag this down to 0.2. You can change this to 0.2, 0.3 if you want to be more dramatic. I'll leave it at 0.3. So now you can see that we're only getting the bottom third of our ramp being applied to each circle. But we now need to figure out how to offset the texture, but independently per instance. And so luckily, there is a texture mode here which has an offset setting. So first we're going to need to create new noise value that can be used to offset the colors here. So let's grab our noise again. We can just grab this first one, copy and paste it so it's the right length. Again, we want to make sure we change the seed. Otherwise, it will be, I mean, unless you want it to be lined up with, say, like the scale. But let's go ahead and do this. So seed 3, I'm going to add a math after this. You can always play with this later, but I liked it going from 0 to 3. So that's the amount that it shifts. But certainly playing with this value, you can kind of see how much, like what the effect is. And then just a null, which I can call text. I'll call this text as well for texture. So go into the channel, TEX. All right, and we can just plug that right into merge here. And then in geo, I'm going to, for the V coordinate, so U is like our, similar to our x-axis, and V is the vertical axis. So I'm going to type in text, and so far it's giving us solid colors, but we want, that's because we're in replace for the texture mode, so we actually want to use offset. And now you can see that we're grabbing different parts of this ramp. And there, you know, now you might be able to understand why we want this to loop is, you know, if we don't do that, you'll actually start to see the line right here. You can even demonstrate, right, where it goes from, you know, we get a disconnect in the color, which maybe you like. I mean, it's something to experiment with. Certainly, it's a different aesthetic. But yeah, for now, we want this to be all smooth gradients. And again, like playing with some of these values will give us more or less gradient. For instance, on the texture, you know, playing with, I don't know what this one will do. It actually doesn't really do a whole lot. So maybe that doesn't need to be there. But in any case, yeah, so you can get sort of different, kind of like different arrangements of color by even changing the seed on your noise. So just a few things you can do. Now, the example that I have, we're already, I might actually want to, so in the interest of time, move on to a different example, but I will just show you some of the post effects that I have over here instead of walking through them, just so that we can get to this other example for the second half of this portion. So yeah, we basically have, let's go into this example, which pretty much we have the same thing happening on the left over here, but I've got some different effects happening for the post effects. Now you'll recognize the same Luma blur post effect that we did for the previous example. And in this case, I also decided to kind of create like an abstract background of, in this case, it's a circle that I only have 9 divisions. I'm using a copy to basically make up 100 copies that are translated. So you can kind of dig into this if you'd like. And then this is being rotated based on our ramp. So that's like one thing that's linked to the timeline. You'll also note that I am kind of manipulating the speed a little bit with, I don't know if I'm actually, oh yeah, here it is. Because I wanted, you're not able to see what I'm doing here. Because I wanted to kind of control the speed a little bit, and we'll look at this later. There's this kind of math and then limit that can be used to sort of, you know, if I want it to loop twice in the same timeline, if I multiply my ramp time by 2 and then loop it from 0 to 1, you'll see that halfway through, I'm actually getting the, you know, looping that process. So that means I can have loops at different rates, right? So my background can be rotating slowly while these are looping slowly while the vertical stuff is looping a little bit faster. One other thing I'll mention here is that like I have this noise in the background that's being transformed from, I'll open this up so you can see it, these like alternating cosine and sine waves. And if you want to know more about that, I do have like a whole tutorial really just diving into this concept of, again, like ways of looping noise. So I don't really cover it. I'm not going to cover it in this workshop a whole lot, but if you look up looping noise, I have only a few tutorials, so it's easy to find. But that's just one way that we can make our 3D or 4D noise start and stop at the same location. So really, like in this case, all it does is make the background continuous. It's really might not even be visible on Zoom. But in any case, again, using a little bit of bloom here, like get really extreme if you want, and also playing with some RGB delay. So that's another thing that you can grab from the image filters. RGB delay is right here that you can use to delay the red, green, and blue channels. So yeah, in the interest of time, I'm going to jump to hopefully get the next example also done in about half an hour. Let me know if you had questions on this one, but this should be a good starter. And we're going to do something pretty similar for the next example. So I might keep some of these things in place to show you. So I'll actually don't need to close this, but okay. So let's the next example I was going to look at is similar in its concept. In this one, we're taking a grid and like moving, you know, a box to position, and then after a period of time, moving it forward again. So kind of pretty simple. Like you'll recognize it's very similar to this process where we're moving it up, and but there's kind of a stage where it needs to stop in the middle. So I might reuse some of this. So let's see if I can do that effectively. I'll leave the render and the kind of geo here, and also let's see. I don't need this texture. I'll leave the render and the camera off though. I'll delete the geo. And I'll leave the timeline because we're going to use that as well. And I'll leave my noise that kind of like loops. And I don't need this for the position. So okay, so let's leave it at that for the moment. And I will be making some adjustments. So for this example, it's generated from a grid, and you know earlier on in the terrain example, we used GLSL to do that. Another very useful way to do it is with a grid SOP. So this can be used to basically generate points in a grid. And in this case, I have this samples parameter actually that I'm going to change. I'm going to add a parameter. We'll remove that one in a moment, but I really want to define the rows, and it'll be the columns too. I'll leave it as a square, but this is going to be the rows and columns for my grid. So I can set this to something like 30, and here's my grid SOP. So I'm going to go to my parameters, drag it onto rows, chop reference, and then also columns. So it's always going to be a square. And I'll create a null. And then from here, SOP2. So now I've got SOP data that is my point position. Now, I really want this noise to be defined by my rows instead. So there's a few ways to do this. I'm going to use an expression here in the channel. So instead of using that parameter I defined, I'm going to type operator parenthesis and then this SOP2 1, and using commas on either side of it. I'll paste this into the chat in a moment. And then dot num samples. So this is you can find this. You go to the Python help. There's information about the chop class, but there's some of these really handy expressions that say, give me the number of samples in an operator. So I can use this, and again, I have to type -1, otherwise it won't line up. So we want this to be the same on both sides. So the next step is we don't really need this samples anymore, so I'll go ahead and just remove it so we don't get confused. Actually, what have I done? Okay. Type 30. 1 second. I just need to delete that. Okay, so now we're good. I didn't have a way of deleting the first parameter. So, okay, we're still good. Let's go ahead and plug these positions in now that we have for our box. And eventually we're going to change the Z value in this case. So we might need to reposition the camera. But I'll drag this into my merge. And now we also need to get our box, in this case, a box SOP. Plug this into a geo comp, okay. And I'll also add a constant material to it. In this case, the effect that I have, there's kind of this like thin wireframe, but also a solid fill. So in this case, I'll actually copy this and be applying everything I do to both geos. So I'll copy this and choose color black and wireframe, topology wireframe. It's really hard to see at this point. I'll make it 2. You can see a little bit of a black edge. You know, once we get more of them and we move the camera around, we'll be able to see it a little bit better. Now, it's also way too big. So in this case, we know the number of rows that we have. And so what we want to do is just take this value, the scale, and divide it by the number of rows. So we will take our box. I'm just going to drag this on here so we get our parameters rows, but then do 1 divided by. So tiny box. We'll have to move the camera around in a moment. So okay, now that we've got that, let's make sure that we select both of these geos. I could even name them color wireframe, just so that we have an idea of which is which. And while these are both selected, go to my instancing, turn it on, drag in the instance operator, and type in tx, ty, tz. So great, we have ourselves a grid. It's a little bit, actually might increase the rows a little bit. I think my other one had a few more, maybe 50. And then also let's zoom in this camera. Cool. Now I might want to look at it at kind of an angle like I had. So this is where I can do the same thing where I create a null and look at the null. The camera is looking at null 3. And then now if I move it around, I can start to, you know, get an interesting angle. Maybe I want it to be fully in frame, but that's good enough. So we get just a little bit of like perspective. And great, so we're looking at it. Now the next thing we need to do is kind of make it move. First, like have 2 stages of movement where it moves up, stops, and then continues to move. And also we want to link the scale in a similar way. The scale actually, I think we can leave the same, roughly. I might change it in a little bit, but I'll leave this here for now and just plug in our scale again. Now we already are getting something kind of cool where, you know, each box is kind of like growing, just like the last one pretty much, but it's arranged on the grid. Now we also want to take this same looping, these ramps that are looping. I'll select them. All right, here we go. And add a lookup. And in this case, this is where I want it to sort of move forward, hold, and then move forward again. So to do this, I'm going to create an S-curve. This is like going to represent one, like the first stage. I will also add to the prepend and append 300, maybe 200, just so that there's like a pause and then it moves forwards. And now I'm going to create another one of these. We can call these both TY, by the way, just so that we know what they are. And this first one, actually, no, I'll delete the second one, sorry, and pull a math out. That way, if we adjust the shape, it stays the same. And the second one, I'm going to range, instead of 0 to 1, go from 1 to 2. So 1 is our like center point, and then use the splice chop. So I think we want, I did it in the wrong order. So here we go. So now it goes from 0 up to 1. It'll hang out there for a second, and then it'll move all the way up to 2. And this is our y value. So now this is my like my lookup table. So if I plug this in, you should see that there's sort of a point where each sample pauses. You can kind of see a little bit of a line across. And honestly, I probably will want to make this not quite as extreme because this is going from 0 to 2. So I will just multiply this by, say, like 0.1. We might have to shrink it more, but that's going to be how much it moves. And for this position, wait, I didn't want that to be ty, did I? I want that to be tz. So I'm going to type tz instead here. There we go. So now we could just select out. So I just don't want tz. We could actually do caret tz if we want. That's another way to say I don't want this one channel. And instead, we're going to plug in our adjusted value. Okay, so here we go. You can see now that they move, they grow and move into position and then kind of move forward. So I think the last thing that we want is color. And in the example I had, they start red and then they move to white, and then as they move away, they turn blue. So to do that, we actually have that information right here, right? So here's where it should be red, 0. At 2, it should be blue, and at 1, it should be white. So we can select, we don't want it to be shrunk in the same way. So let's create a select and grab this lookup data. So this is going to be used to drive the color. And I can create a ramp in tops. It's really the best, like the only way to drive color. I mean, there's other ways, but let's just use this. And again, create some sort of set of 3 colors. Again, we might want to go in here because this is our resting value, so we need to make sure that this is 0.5. And plug this into a null. And then now we want to turn our top data into chops. So middle mouse click, go to chop, top 2. And I also might want this to ease in and ease out. So you can see when I change that, we get like these smooth color curves, which we might adjust these in a moment. Let's see how they actually look when we plug this into a lookup. So get this lookup chop for the index and then plug this in. One thing that we want to do is adjust our index range. So this is going from 0 to 2. We can do that on the lookup table, which is like uses less operators than say adding another math to rearrange it. So so yeah, now we've got our RGB. I'll leave the A in there. We're not going to really use it. Call this color. This is a null. Something else is called color. Oh yes, my geometry. Okay, and plug this into the merge. And then now we need to go to our, really just our color. And under instance 2, we have this color section where we can just type RGB. And there you go. So now it starts red, moves to white, and then when it's leaving, we end up with blue. So yeah, in the next sort of 5 minutes or 10 minutes or so, I'll show you a few kind of the post effects that we added to this, or I added to this. So like one thing I did was, I'll go back to the original example again. So so this one, the background here, I'm using 2 different ramps They're really subtle, and driving the background between red and blue with a cross. So this kind of like fades the background. It starts red and then turns blue and then back to red a few times. And I'm also using a bloom with sort of very sensitive threshold and intensity settings, because this gets out of control very fast with white, like a lot of white and light values. And a level, which is really just bringing the black level up. But again, this all of this sort of color work for me really has to do with exactly what colors I'm using, and it's very much a matter of like taste and just like tweaking parameters back and forth. So I might change the background, decide that I don't like the colors anymore, go back, adjust those to make them duller so that they pop more in the bloom. So it's really just like a back and forth at the end to get it where I like it. But really this is where you can also just like really play with it yourself. Now, I'll ask, are there any other questions on these last two examples? And while I'm waiting, if people have questions or issues, also, so in addition to those examples, I need this to go away. Okay. Okay. A couple other things that I've done with these. One is you can use a top, like this one uses a top and then converts that entire top to chop data to drive the scale, for instance. And so that's how we can get like these patterns. So that's one thing to experiment with. Again, like here's an instance where I'm kind of stacking that grid on top of a bunch of other, essentially like another box, right? So it feels like we're completing something, but really all that I'm animating, it's the same as what we're looking at here, essentially. Also, we looked at this last example. Here's one where I'm using spheres and the camera is positioned differently, so you can start to think about how you can add different geometry or camera angles, or like different shapes. So here's one with box, like rectangles. And then lastly, I don't really have time to make this one today with everybody, but this is like the poster art that used to kind of like for the workshop. And so this is using the same kind of principle. The major differences in this one is this one has a PBR material and environment mapping, so that there's these reflections, and also the geometry being used here. And I'll post this link in here. There's this cool resource on the forums called the Polyhedral database, and so I'm linking that in the chat. But this provides all sorts of great kind of like Platonic and Archimedean and Catalan solids that are procedurally modeled. So so that example uses one from that set as the, and adds kind of rotation too. So there's a lot you can kind of do to experiment. You can see the depth of field effect as well with the Luma blur. So a lot of things to kind of explore in that one beyond kind of what we looked at today in these examples. So just to pull up I think I have it over here. Oops, this is the chat. Oh, it's in generators for some reason. Okay, so that polyhedral database looks like this, and you can see there's all sorts of interesting kind of like forms to use, and you can look inside of them and actually see how they do them in SOPs, which honestly, like, I don't know half of these techniques because I don't play with SOPs that often. So really cool resource in like a tool that lets you explore them in different ways. So yeah, I just wanted to link that. It's probably about time for the next break. So yeah, does that sound good, Yasushi? And then we'll
sure.
loop back in 10 minutes for the last example.
Yeah, okay, cool.
Awesome, thanks everybody.
Thank you, everyone.